Hello people, hope you are doing well. In this video series, we will be learning about JavaScript, the performance of JavaScript, how JavaScript performance is improved by its internal engine using some techniques like JIT, what is assembly, and what's the new feature that will boost the performance of JavaScript called WebAssembly. Okay, so performance. Performance is the single most important thing about your app that matters not only to you but also to its user. User don't want to be stuck on a single page. User want interaction with the page, and user doesn't want your page to get hang. Okay, so performance aspect is important for JavaScript, and how JavaScript achieved that performance aspect first was using just-in-time compilers. Let's learn a bit history about JavaScript. Okay, so JavaScript was developed in 1995. It then wasn't designed to be fast, and it wasn't fast for at least a decade. After 2008, uh, this was a period when multiple browsers started coming out with their own implementations of JavaScript engine and started to include something called JIT, just-in-time compilers. What JIT does is it could see the pattern in your code, and based on those patterns it tried to optimize your code. That's what JIT does. JIT made our code 10x faster than it usually used to be, and this was the very reason things like Node.js came into being. If JIT hadn't been there, there would have been no server-side JavaScript. Okay, so JIT played a huge role in Node.js. Okay, so that was an inflection point when JIT was introduced, and is going to be another inflection point after people adopt using WebAssembly in their code, and WebAssembly completely gets developed. Okay, so to understand how performance is a thing with our code, we must understand how our code interacts, how we write our code, and how our code interacts with the machine. Okay, the better the code interacts with the machine, or the faster is our code, the better is our performance. Okay, so let's consider a scenario where we are trying to talk to the machine. Whatever language we use, the programming language that I use is mostly JavaScript and Python and Go language. Okay, so these languages, believe it or not, are high level languages designed to be human interpretable. Like I recognize the word function. Okay, the function is a word that my mind can understand. The where is a word variable my mind understands what it is. Int is a data type in C language or Java that my mind understands as it's an integer. Okay, so these are high level languages developed for human interpretations, not for the machine interpretation. Machine understand binary code. Okay, so your code, whatever you write, is to be converted into binary. Okay, so this image reference was taken from Lind's blog post, and where he gives an example of Arrival movie when aliens come to Earth and we are trying to interact with them and trying to communicate with them. They speak different languages, we speak different language, so there needs to be some translator in between to help us communicate. And for computers, there are two types of translators. First is the interpreter, second is the compiler. What interpreter pretty much does, it translates your code on the fly. It will read, say, this line of code for I equals to 0, I less than length, I plus plus, and it will translate it to a binary. Okay, something like that. But what a compiler does, will read throughout your code and will generate a binary at the end when it has read your code, and will use that binary again and again whenever that piece of code gets hit. Okay, let's say I have wrapped this into a function and this into a function, and I call the function pretty much many times in my code. So this loop runs many times and this loop runs many times. If we use interpreters, whenever the function is called, this loop will be translated into binary, and for every iteration of the loop, that will again translated into binary. So that is a huge, time waste. I am translating almost the same thing into binary again and again. On the other hand, what compiler does is it has stored that compilation, and thus whenever it needs the compiled version or the translated version for another iteration, it will just simply pull that from the memory. Okay, so at present you think the compiler is good, but there's a problem with the compiler. Compilers are slow. How they are slow? It needs to completely study the code, optimize that code, and generate then a compiled version. Whereas the interpreter reads the code, translates it immediately to a binary, again reads the next code, translate it to immediately a binary. Thus, it's easily to get up and start with interpreters than the compilers. Okay, so what we did with JavaScript, we took the best of both worlds. Our best of both worlds, we integrated something called monitor or profiler into the JavaScript engine. What it does, first of all, every code is run through the interpreter. As a piece of code starts to run many times, it is said to get warm. The monitor or profiler knows this thing. As a piece gets warm or runs a lot, it will be called a hot piece of code. It understands that if I run this every time through an interpreter, it is a huge waste of time. So I must kick in the compiler here. Therefore, it kicks in a compiler called baseline compiler. What baseline compiler does, it will read that piece of code which was getting warm, and it will translate, or it will store the compilation into something called stub. Each line of the code, say sum plus equals to array I, is a stub. Okay, and say if the monitor sees that the looping is hitting the same code with a similar variable, it will pull out the same compilation. What is meant by similar variable and same compilation, I will explain it later. Okay, so optimizing compiler is kicked in after the baseline compiler if the monitor saw that the code was too hot, means there was suppose 100 iterations, so it kicked in the optimizing compiler. What optimizing compiler looks at? Optimizing compiler says, okay, for the previous compilation that resulted from the baseline compiler, what you mainly were looking at was the variables declared had always the same type. Okay, have always the same type throughout the loop iterations. If it had the same type, it was compiled and it was reduced to a simple machine level translation. What optimizing compiler will do, it will make some assumptions. Say, it will assume that a array is an array, sum is an integer, array I is an integer. If it saw that for say let's say 10 or 20 iterations the thing was true. Okay, saw that the sum was integer, it saw that the array ARI is an array, it saw I was an integer, uh, array I was an integer. Thus it made assumptions that for the future iteration this will be true. Okay, in the case if it was array consisted of an object, it could have made assumption that the object belong to same type, or I should say same shape. What I mean by same shape is that objects have uh, same properties in the same order. Okay, but we know that there is never guarantee with JavaScript for the same types. An object for this array, if no, that's assumptions could be true for the 99 iterations, and for the 100 iteration it could become false. Okay, and if it does become false, JIT simply assumed that it made the wrong assumption, and it will go back to previous compiled version of base compiler or even the interpreter if it suits, whatever suits. Okay, so this process of bailing out of the compiled version is called de-optimization. See, usually the compiler makes the code faster, but as with JavaScript, there is no guarantee that there were similar types, object were of same shape, and thus we cannot make assumptions for these, since like it was integer and same object, shape, all those things. We cannot make those assumptions. So bailing out was necessary because it could have, if I run for 19 iteration at 100 iteration, I saw that, okay, whatever I assumed previous is not true. Why did I even compile the previous version? It took a lot of time to run code through a compiler. So it is better if I run this code through an interpreter. You can be sure to have same type by using some type checking libraries like TypeScript. Those really help to, make sure that your code has strict type checks. And if it has a strict type checks, it is more likely to be more optimized than the previous code which you would have written in JavaScript, which would have just skipped out of assumptions and have changed its types at the very end. Okay, so here is an example. I have this code, a function which is called arraysum, and it runs a loop throughout the length of the array and it sums the array. Okay, so for each line, a stub is created, and for this sum plus equals to array I, it looks simple. Okay, but what here is taking place is really complex. There are a lot of things that takes place here. So we will examine this line. Based on this line, it will be decided whether this code will be optimized or not. Let's see. Okay, when this line comes, sum plus equals to array I, what compiler will ask? Compiler will ask that is sum an integer? Is there may be answer yes, maybe answer no. And if it's an integer, okay, I assume it's an integer. Next question would be like, is ARR an array? Because in JavaScript I can do a string also, so I have to make sure that ARR is an array. Okay, ARR is an array. Good. Is I the integer? I is an integer. Okay. Is the ARR I the ith index of the ARR array is an integer? Okay, it's an integer. And if these all were true, it created a stub, this one. And for each choices that we have at these diamond shapes, it creates stubs, or it creates different stubs compiled versions. These are all different compiled versions. Okay, so it runs through the code asking these questions every time. See, is some first iteration, it would be like, is some an integer, is AR an array, is I an integer, is ARI ARRI an integer. For second iteration also, for third iteration also. If this comes to be true for few iterations, JIT would assume that this would be true for all next iterations of the loop, and thus it has made these assumptions that I know sum is an integer, I know I is an integer, I know ARR is an array. Only thing that I have to check now is ARRI an integer or not. The ith index of this array is an integer or not. Okay, was this a thing that I need to ask at each step? I cannot assume, because in JavaScript, arrays don't have a strict type. You can push anything into array. You can push an object, you can push another array, you can push a function, you can push a string, you can push a number, hell lot of things. Okay, so at each step, I need to make sure that ARRI is an integer, and if it's so, then it's good. I have a compiled, optimized version of the code with these assumptions in mind and asking these steps for throughout the loop. If it was true, JIT would prepare a compiled version for this code. Okay, and Thus, this code will be optimized. If, anyhow, uh, the assumption became false, it will bail out of this process and will either use the previous uh, baseline compiled version or directly use the interpreter. Okay. So in a nutshell, JIT makes JavaScript faster. JavaScript is unpredictable with types. That's the one reason language took off, but that's the another reason why there are so many complex engines being built to optimize the performance of JavaScript, why JavaScript has a limited performance. And to improve the performance, there are two important things. First, your code that you write is the most important thing. So I always suggest use something like type checking library. TypeScript is good choice. And after that, after you are sure that you have used TypeScript in its most strictly possible way, JIT will make sure that your code is more optimized. Okay. So what JIT adds some overheads during the runtime, including the optimization thing, memory used for monitors, bookkeeping, recovery information for when to bail out happens, memory used to store the baseline and the optimized versions. So these are the overheads. Okay. So what we will do is to remove how we remove these overheads and how to deal with overheads, and that's the one thing WebAssembly will do for it. Yes. And thank you. This was our presentation. Hope you like it. Goodbye.